All right, let's dive into something that powers pretty much your entire digital life. We're going to pull back the curtain on the hidden architecture that lets your favorite apps serve millions and sometimes even billions of people without breaking a sweat. I mean, have you ever really stopped to think about it? You open up Instagram, scroll through hundreds of photos, watch a movie on Netflix, call an Uber, and it all just works. It's seamless. But behind that incredibly simple experience is a massive engineering puzzle. So, seriously, how do they pull it off?
Well, the secret isn't just about writing more code or buying faster computers. Nope, the secret has a name, and that name is system design.
So, what is system design really? At its core, it's the master plan. It's the blueprint. It's the process where you figure out all the pieces of the puzzle, the architecture, the components, how they talk to each other, before you even write a single line of code, all to make sure the system can handle whatever you throw at it. And this is the perfect way to think about it. You wouldn't just start stacking bricks randomly and hope a skyscraper appears, right? Of course not. You need an architect to plan out the foundation, the steel frame, the elevators, the plumbing, everything. System design is exactly that, just for the digital world we all live in. So you might be thinking, okay, but can't I just build my small app and then, add more servers if it gets popular? And that's a fair question, but, well, it's just not that simple. The problems you have to solve when you go from a handful of users to millions of them are completely different. And the difference is night and day. A small app for a school project. It can have a simple setup, but a massive global app, it has to be blazing fast. That's performance. It has to be able to grow to millions of users without falling over. That's scalability. It can never go down. That's reliability, and it has to protect all of our data. That's security. These are the huge challenges that system design is all about solving. Okay, so if we're the architects of these digital skyscrapers, what's in our toolkit? What are the actual building blocks we use? Let's take a look at the core components you'll find in almost every single large-scale system out there. First up, we've got load balancers. The name is pretty descriptive, but I want you to literally picture a traffic cop for the internet. When millions of requests are flooding in at once, the load balancer stands at the front gate and smartly directs each car, each request, to the open lane or the server that's least busy. This is what prevents a total traffic jam and keeps the whole system from crashing. Next up, databases. Think of this as the system's enormous, perfectly organized library. Every single thing, every user profile, every photo, every comment, every like, has to be stored somewhere it can be kept safe and found again in an instant. That is the critical job of the database. Then we have one of my favorites, caching. A cache is basically the system's short-term memory. It keeps the stuff you look at all the time, like your main social media feed or a viral video, in a special, super fast place that's easy to get to. This is the magic that makes your feed load instantly instead of you having to wait. And finally, let's talk about CDNs. Now, this is really clever. Imagine you're in Tokyo and you want to watch a video that's stored on a server in California. The sheer physical distance the data has to travel would cause lag. A CDN solves this. It's a worldwide network of servers that keeps copies of content. So when you ask for that video in Tokyo, you get it from a nearby server right there in Asia. It's like having thousands of local warehouses for data all over the globe. Okay, so we've got our toolkit, load balancers, databases, caches, and CDNs. Theory is great, but let's see how all these pieces actually snap together. We're going to follow the journey of one single photo as it gets uploaded to a service like Instagram. So let's walk through it. You've got the perfect picture on your phone and you hit upload. Step 1. That request doesn't just go to one place. It first hits a load balancer, our traffic cop. That load balancer finds a healthy, free server and sends your photo there. That server then saves your photo into the main database, our giant library. To make sure your friends in another country can see it right away, that photo gets copied out to the CDN, our global warehouses. And the next time you open the app, your feed is pulled from the cache, the short-term memory, to give you that lightning-fast experience. See? Every piece has its job. It's like a symphony. Now, this might all seem super abstract, like a problem that only the giant tech companies have to worry about. But here's the thing. Understanding these ideas is incredibly important for anyone who builds software at any level. Because learning system design teaches you how to think bigger. It teaches you how to build things that can actually grow and last. If you ever have an idea for an app that you hope will be used by more than just your friends, you need to know this stuff. And let's be practical for a second. This is one of the biggest topics in technical interviews for major tech companies. It shows them you don't just know how to code, you know how to build. So you see, system design is so much more than just a technical topic. It's the art and science of building the massive, resilient systems that connect our entire world. It really is the blueprint for the digital age we live in. So the only real question left is, if you had the blueprint, what would you build?